So this is to the north. This is east, south. This is west. We have a force of 15 Newton. Making an angle of 60 degrees to the east. This is a force of magnitude 15 Newton. Then we have another force this is 19 Newton. Making an angle of 0 with X with the east and 90 with the north. Then another force along the south. This force has a magnitude of 27 Newton. It makes an angle of 0 with the south or negative y-axis and 180 with the north. We have another force, 11 Newton. This is 11 Newton. The magnitude is 11. The angle it makes with this X, this is 30 degrees. Then we have another one of magnitude 16. Makes an angle of 45. Newton. The angle it makes with the X, this is 45 Newton. So we have 1, 2, 3, 4, 5 forces. Okay, making different angles with the X or Y and then the east and north respectively. Class, your first work is that resolve these forces from 1 up to 5 into their various components. They are X and Y components. So start work. Resolve each one of them, okay, to their X and Y component. When you finish, the next instruction will be given. Please, class, are we okay? Are we okay?
Yes.
All right. Please, time, we are using about 10 minutes for this. So let's hurry up. So we have F1 is 15 Newton. It makes an angle of 60 degrees with the X, meaning 30 degrees with the Y. We have the second force, which is 19 Newton, making an angle of 19 Newton, 0 degree with the east or X, and 90 with the Y. Then the next force, 27 Newton, making an angle of 0 with the negative X or the south, an angle of 180 with the positive, with the north or positive Y. Then we have a force of 11 Newton, making an angle 30 degree with the negative X axis. Then lastly, 16 Newton, making an angle of 45 with the X axis. This is 30 degrees. So let's choose 15 Newton to be F1. This is F2, F3, F4, then F5 respectively. So resolve each and every one into its components. So let's please express our values in decimals, 2 decimal places. So express Fatima, please mute yourself. Express the forces into X and Y components. Hey, Fatima, let me mute all. Are we through? Class, are we through? Hello?
There is 2 more minutes.
Hurry up. So, either Akusia, Alithea, Anita, Augustine, Barack, Caleb, Daisy, Elikem, Frank, Rempoma, Saki, Giovanni, Gerard, Gideon, Asana, Isaac, Jacob, Jaila, Jessica, Kesoa, Marilyn, Mary, Michaela, Michelle, Miles, Nana, Kwame, Antiwa, Nicole, Davis, Ella, Priscilla, Ohene, Fatima, Yabukwa, Yasmin, and Janelle. So the first force in resolving it to the various components, whether you use x-axis or y-axis, the value is the same. So F1 will certainly be 15 cos 60 and 15 sine 60. This is also equal to, when you use the angle to the y-axis or not, 15 sine 30 and 15 cos 30 degrees. So whichever way you look at it, the value must be the same. Sine 30 cos 60 half. So this is 7.5. 7.5 Newton. Then sine 60 is 0.866 or root 3 on 2. So let's express everything in decimal. Let's
12.9.
12.9. Is that 12.9?
Yes, sir.
I just want to 7.50 and 12.9. Okay, let's please take it as approximately 13. Okay. I'm doing that because I have a template here and I want us to work with the answer we have here. Okay. Then F2. F2, the angle it makes with the X is 0. And it makes an angle of 90 with the Y. So 19 cos 0 and 19 sine 0. This must be equal to the angle it makes with the y, which is 19 sine 90 and 19 cos 90. This is equal to 19 and then 0, meaning it has a horizontal component and no vertical component. F3. F3 makes an angle of 180 with a positive y. Okay. So 27 sine 180 and 27 cos 180. Here I'm only considering the angle it makes from the north, this whole angle. So, meaning it only has a vertical component and no horizontal component. Sine 180 is 0, cos 180 is negative 1. So minus 27. Minus 27 Newton. F3. Sorry, F4. F4 makes an angle of 30 degrees with the x-axis, and from the north, it makes an angle of 240. When we subtract 30 from 270, and when we take the angle from the north, it is 240. So let's only use the angle it makes with the x. So we have 11 cos 30 degrees. But this x component is negative, so minus must come. Negative. And 11 sine 30 degrees. Within this quadrant, y is also negative, so minus, minus. And we can equate this to the angle it makes from the north, which is 11 sine 240, 11 cos 240. The value will be the same. Cos 30 is 0.8660. So 11 times 0.8660. Please quickly help me. 11 times 0.8660. Are you there?
So please then values again.
11 times cos 30. Hey,
9.53.
come again.
9.53.
Okay. 11 times sine 30. Sine 30 is half.
5.5.
5.5. 0. Then the last vector F4. The last one is F5. So F5, which has a magnitude of 16 Newton, acting at 45. So if we use the angle it makes with the x-axis, we have 16 cos 45. And within this quadrant, x is negative. So minus 16 cos 45 and 16 sine 45. Within this quadrant, the y component is positive. Cos 45 is root 2 on 2. So h times root 2. H times root 2. H times root 2 class, or 16 times cos 45. Hello?
11.31.
11.31. H times, oh, okay. Okay, so positive 11.31 Newton. So these are the x and y components of F1, F2, F3, F4, and F5, respectively. How many of you got all the components correct? I asked you to resolve them into components. So how many of you got everything correct? Raise up your hand if you did. Prempoma did. Hey, the rest of you, what happened? Kasua, Akwentua also did. Hey, Mary, who else? Kasua, hi, Augustine, Alitia, okay. Now the next thing is that let's look for summation f of x and summation f of y. So summation f of x and summation f of y. So all the x's in each of the components. So 7.5 plus 19 well, okay, Augusta, let's finish it. 7.5 plus 19 plus 0 minus 9.53 minus 11.31. This is equal to, I have finished it for me, 7.5 plus 19,
5.67.
okay, 5.67.
67.
So 5.67 Newton. Priscilla, are you there?
Yes, sir.
Then why? 13 plus 0 minus 27 minus 5.50 plus 11.31. What's the total?
Negative 7.69.
Negative
7.69.
Is that so?
Negative 8.19.
I'm coming. Okay. So this and what I have here is a different question. So 13 plus 11.31. This minus 27 minus 5.50. Is that negative what? 8.19.
So this is supposed to be negative 8.19.
Okay. So let's find the resultant. Plus, once we have summation f of x, summation f of y, help me determine the resultant. Help me find the resultant first. Anita, are you there?
Yes.
What is your value of the resultant?
9.96.
So R is equal to 9.96 Newton. So this is the value of the resultant of all the 5 forces. Help me determine the direction from the north. The direction of the resultant from the north, class. Help me determine the direction of the resultant force from the north. The direction of the resultant from the north. And now going to
So please, I don't know whether it's correct, but I got 55.22.
the direction of the resultant force from the north.
Yes, 55.22 degrees.
Okay, more views. So she had 55.2, so approximately 55. Okay, let's see it. So in determining the direction of the resultant, I have to represent summation x and y on the Cartesian plane. From what we had, summation x is positive, summation y is negative. So summation x is positive 5.67. So that must be written here. So summation f of x 5 points. This is 67. 67. And summation fy is also negative. Once it's negative, it must to come here. So 21 straight away, it means that your answer wouldn't be correct. 8.19. Because if we are measuring the direction from the north, then it must be more than your answer 55 as you had. So once we have summation f of x in this direction, summation f of y in this direction, obviously it means that the resultant would act along this diagonal in this direction. Okay, the resultant of this will act in this direction. So our resultant, which we had, will be here. So they are using equal vectors. Can be here. 20, are you with me?
Yes, please.
And this side is perpendicular to this. So this is also summation f of y, which is 8.19. We had negative, but it is because we had negative. That is why the summation f of y is brought along the negative y axis. So this direction takes care of the negative value. So you don't need to repeat that. Therefore, let's find this angle first. Let's assume this is alpha. So when we take the tangent of alpha, we have opposite, which is summation f of y on summation f of x. This is 8.19 divided by 5.67. Please give me this ratio. 8.19 divided by 5.67.
1.44.
1.44. So alpha, therefore, is the tan inverse of 1.44. What's the tan inverse of 1.44?
55.22.
So approximately 55 degrees. But that's what you had. So if you are determining the direction
Yes,
of
please.
the resultant from the north or the positive y, then we must turn through this angle. We must turn through this angle. Therefore, direction of resultant from the north, then will be 90 plus 55, which will give us 145, right? Degrees.
Yes, please.
Okay, so when you add this, your direction of 55 is the direction of the resultant from the east. If you are at the east, then you must turn through this angle to determine or to face the direction of the resultant. But we want to follow bearing. Bearings, angular measurement is taken from the north. So that's what I mean. Now, class, help me determine the direction and magnitude of the equilibrant. The direction and magnitude, or the magnitude and direction of the equilibrant. So I'm waiting for you. The magnitude and direction of the equilibrant. So I'm giving you, I think 6 minutes will be okay for this. Hey, Asida, Marilyn, Osei, and Kujo, do you follow what is happening? Marilyn. My two Marilyns, do you follow the discussion?
Yes, please.
Okay. So you are looking for the magnitude and direction of the equilibrant. Two minutes more. I've moved to the next page, Augustine. So one the resultant plus the equilibrant. And here my equilibrant is R prime. Must be equal to 0. So equilibrant R prime must be equal to the negative of the resultant. Components of the resultant were minus 5.67 and minus that. So 5.67 and minus 8.19. Therefore, the component of the equilibrant would also be minus 5.67 and positive 8.19. Frank Martin. Therefore, the equilibrant R prime will be equal to the square of this, its x component, which will be the same as that. Your minus 5.67 all squared plus the square of 8.19. The value will be the same as what we had for. Okay, so we must have 9.96. 9.96 Newton as the resultant. As the equilibrant. Don't forget the equilibrant has the same magnitude as the resultant. That's why. Now let's look at the direction. If we redraw this, the component of the equilibrant, x is negative. So the x component will be here. So x component will be along the negative x, which is 5.67. And then the y component is positive, which will always also be here. This is 8.19. Therefore, the direction of the equilibrant will act here. Will act there. R prime. Okay. And so when you find this angle, this angle must also be 53. Let's check it and see. Tan of alpha opposite, the opposite is 8.19. Adjacent is 5.67. Please help me find the value of alpha. Yes, 21 and co. Oh, who is helping me? The value of alpha.
Isn't it the same 55 degrees?
I just needed a confirmation. So if you are looking for the direction from the north, then this time around, we must add 55 to 270. 270 plus 55, because we must turn through this angle. Or the other direction, don't forget, when we turn through this angle, 270 plus 55, we are going clockwise. The shortest possible direction is subtract 55 from 90. And that will be 35, right? So the shortest possible direction can be turning through an angle of 35 degrees anti-clockwise from the north. So this is the shortest possible. When you go this angle, this is 325. It will be longer. But when you are also here and you turn an angle of 35 degrees anti-clockwise from the north, you face the direction. So 325 can be, it's a possible direction, and this is also another possible direction. If you don't want to use this and you want to use this one, the equilibrant has the same magnitude as the resultant, but its direction is opposite. So while the resultant acts or faces this direction, the equilibrant must go opposite to that same direction. So if you want to go this, follow this, then the equilibrant can also be determined using this analogy. And it's the same as what we've done. So this is our equilibrant. Once this is alpha, this is also alpha. So 55, 55, and this will be 35. And so if you want to measure it from the north, then 55 plus 270 or 35 degrees counterclockwise. So these are two possible ways of determining the equilibrium. Please, is there any question? Okay. I sent a trial work to some of you. I sent this trial work to some of you. Let me repost it so that all of us actually benefit from the work. Yes, class, the question is on a page. Three vectors P, Q, and R are 3 units due south. So P is 3 units, has magnitude of 3 units due south, 4 units due southwest, meaning Q is 4 units in the direction southwest, and 5 units due east. R has a magnitude of 5 units and it is due east. The first question demands that, okay, you have to find by calculation the magnitude and direction of I, P plus Q. I, P plus Q, I, P plus Q plus R. I, P plus Q minus 2R. So we are told P is 3 units due south. Magnitude 3 units due south. Then Q 4 units due southwest. Four units due southwest. And R 5 units due east. Find P plus Q, P plus R. So first represent the vectors on the Cartesian plane. Represent the vectors on the Cartesian plane. Okay, Gerard, thank you. Gerard is so quick on that. This is north. This is east. This is south. And then west. P is 3 units due south. So this is P, 3 units. Then Q is 4 units due southwest. So Q divides southwest, that quadrant, into 2 equal parts. This is Q. Four units. Then R has a magnitude of 5 due east. So find P plus Q. P plus Q. Are we through with P plus Q? Plus I can find P plus Q using 2 different methods. I can use the method of resolution of forces into components, or using cosine rule. Let's first use cosine rule. If we use cosine rule, vectors are equal no matter where they are if they have the same magnitude. So I want to draw the equal vector of P. I'll place it on the head of Q. So this can also be P placed on the head of Q. This is the equal vector of P, which is also 3 units. You can also draw the equal vector of the vector Q. and place it on the head of P. This is also Q of magnitude 4 units. Now, whether you look at it from this side to this side or from here to here, you realize that the resultant will be drawing from here to here. So the resultant can be here. Let me change the color. This can represent the resultant. So that this line is following direction. This is Q. This is also P. So I can then say that by triangular law of vector addition, this is P plus Q. So P plus Q is the resultant. So using this cosine rule, the resultant is equal to, the square of the resultant is equal to P squared plus Q squared plus 2 times the angle between them, 2 times P times Q times the cosine of the angle between them, which is 45 degrees. So P plus Q squared, which represents the resultant, is equal to 3 squared or 4 squared plus 3 squared plus 2 times 4 times 3 times cosine of 45. 16 plus 9 plus, cos 45 is root 2 on 2. So 12 root 2. 12 times root 2. 25 plus 12 times 1.414. Root 2 is 1.414. Please, I have put everything together for me. 25 plus that. Augustine 21, please help us so we can be quick. Anita, talk. Ella, multiply that and add that to 12, 25 for me.
So please, 27.83.
27.83. Therefore, P plus Q is equal to square root of 27.83. What's the square root of this?
5.28.
5.28 units. Giovanni.
Sir, please, I got 4.94.
As your final answer.
Yes, sir.
We will confirm, so don't worry. Another hand is up. Let's see.
Sir, please, is that 12 root 2?
Yes. That is
Sir,
12
that
root
means
2.
that means the answer is 41.97.
This is 16 plus 9, 25 plus 12 root 2. and root 2 is 1.414. So let's all confirm. So we have 12 times 1.414.
Sir, please, it was I who made a mistake. I didn't see 12. I saw 2.
I'll beat you.
Sir.
That's 12. Okay, so let's correct it quickly. So 12 times root 2. But root 2 is 1.414. So multiply that by 12 and add that to 25.
Sir, it's
41.97.
41.97.
Okay, so P plus Q is that 41
.97.
before taking the square root.
Yes, sir.
Okay, so what's the square root of that?
6.478.
6.478. So 48 units. Let me confirm the answer. I sent the solution to some of you.
Yes, please.
Yeah, so approximately 6.5. Yes, approximately 6.5. That's correct. Another way of doing the same thing is that we can resolve P and Q into components. We can also resolve P and Q into components. Let's quickly do it. So P acts at 0 to y-axis. Okay, the negative y-axis. So it means it has only a vertical component which is negative and 0 horizontal component. So the component of P are 0 and negative 3. Then let's resolve Q into components. It makes an angle of 45 both with the x and then the y. So components of Q. The components of Q, we have, what's the magnitude of Q? Q is 4. So 4 sine 45. And within this pattern, both x and y are negative. So 4 sine 45, 4 cos 45, which are all negatives. And sine 45 root 2 on 2. So this is minus 2 root 2. This is also minus 2 root 2. When you are, what is 2 times root 2? When you are 2 root 2.
Sir, in decimals.
Yes.
Sir, please, 2.83.
So minus 2.83 minus 2.83. So sum up all the x's and y for both P and Q. So summation x is equal to 0 minus 2.83. Then summation y, we have negative 3 minus 2.83. This is equal to negative 2.83. This is also equal to negative 5.83. So once we are looking for the magnitude of P plus Q, P plus Q will be equal to the square root of hx and hy. So minus 2.83 squared plus minus 5.83 squared. And you must get the same results as we had. Okay. You must have approximately 6.50. If you are not getting it, you let me know. If you are not getting it, let me know. Ada, aren't you getting it?
No.
Why, Ada, what is 2.83 squared?
Please, my phone is spoiled and my calculator too is spoiled.
So you are calculatorless. Okay. But you are square that for us.
The whole thing or the
Okay, what's the whole
in
thing? 2.83 squared plus 5.83 squared. So either are you using laptop?
yes, please.
Okay. But you are wasting time.
please 41.78.
So the square of 2.83 is what I've written. Okay, and then the square of, let's take our time to take the rest through. The square of 5.83 is also 33.99. So either when you sum up what is within, when you sum up this 8.0089, we have 41.99, approximately 42. So let's take the square root of 42. Square root of 42 is 6.48, approximately 6.5. Okay, so that represents P plus Q. P plus Q is equal to 6.50 units. Please, Ada, are you okay?
Yes, please. So the question so I is finding for magnitude and direction.
This
Like
this this
the
one
whole
this one only asks us to find the magnitude. So once calculate P plus Q, that's the magnitude of the two, or the resultant of the two vectors.
okay.
All
Okay,
right.
thank you.
All right. So class, work on P plus Q plus R. What will be the resultant or the result of this time P plus Q plus R? And if I can also answer this using two methods, the same two methods. You see, we found P plus Q. We'll look at something. Let me clear all these parts. And you can also use resolution of vectors. Okay, we've resolved P, and I think that is shorter. Let's do the simple thing, then later you explore. We've resolved P and Q into components. So resolve R into component as well. Either what will be the X and Y component of R? What will be the X and Y component of R, either?
5 Newton and 180 degree.
We are looking for the components, X and Y component of R.
Yeah.
So look at it again. Somebody else to also try. The X and Y component of R, the vector R. Anybody? Oh, Anita. Okay, Yasmin.
Please, 5 and 0.
5 and 0. Yeah. It has only X component and 0 vertical component. So it's 5 and 0. So P plus Q plus R means that we need to add all the components of, so 0, -3, this plus -2 √2 -2 √2. Of course, we can change it to decimal. And then the component of R, 5, 0. Let's add everything. We got 2 √2 to be equal to 2.83. So 5 minus 2.83. Okay, this will be the horizontal component or X component of all of them. This is 2.17. Then -5.83. -5.83 will be the Y component because this is 0. Okay. Therefore, P plus Q plus R will be equal to the square root of X component, the squared, plus minus 5.83 squared. Please give me the final answer. I'm waiting for you, class. Hello, what's the final answer?
6.22.
6 points.
22.
6.22 units. So this will be it. I can also do differently, work this out differently, and look at it. This is the red, this thing here is the resultant of P and Q. So I can use the vector P plus Q and add it to R. Open your eyes to see how we are going to go by this. We did not determine this angle. That would be the problem. We should have determined the angle. Let me undo and then check something. We should have determined this small angle here. If we calculate this small angle, okay, the angle the resultant makes with P, then we can add that to 90. And that will give us the angle between R and P plus Q. Plus, I hope you understand what I'm saying. If we had determined this small angle, we'll add it to this and then use cosine rule to find that. I want one of you to do that after the class for me. Use the cosine rule to still find P plus Q plus R. And what you have to do is that you must determine the direction of the resultant, the small angle. Then you add it to 90 to get the angle P plus Q mixed with R. Then use cosine rule to find the resultant, and you must get the same result. Giovanni and Co, please continue, and the rest of you. I hope you are following what I'm saying.
Yes, please.
So first, you must find the direction of the resultant P plus Q, this angle half, or small angle alpha. When you get alpha, because you are now looking for P plus Q plus R, you add that angle to 90 to get the angle between P plus Q and R, and you use cosine rule to find the resultant. And you must get the same results as this. So, an assignment for you there. Okay, so the next problem is on P plus Q minus 2R. P plus Q minus 2R. I want you to think through and do it. Okay, do it before I come in. So how would you solve P plus Q using resolution of vectors into component P plus Q minus 2R? Don't forget, it's just a number multiplying R. Then after that, you subtract the component of 2R from P plus Q. That's all. So I'm waiting for your trial. Before I will come in. We need PS 03, 0, -3, Q is minus 2.83, another minus 2.83. Then minus 2 times R. R is 50. So 0 minus 3 plus minus 2.83 minus 2.83, then minus 10 and 0. When we multiply 2 by r. So when we combine everything, we have minus 12.83, then minus 5.83. Please, is that what you got? Class, is that what you got?
Yes, please.
Yes, please.
Okay. Therefore, P plus Q minus 2R is equal to square root of 12.83 squared plus 5.83 squared. And I'm doing this because when you square a negative, it will become positive. So what's the final answer? What's the final answer? Hey, where are
Sir,
they?
please. 14.09.
Come again.
14.09.
Okay, units. This is 14. Let me see if that's what I got in my. Okay, so approximately 14.1.
09.
Okay, approximately 14.1 units. And with this, you see, when you take your time to resolve this into component, you can also determine their directions as well. Okay, oh, okay. The question actually asks that we find a magnitude and direction. Okay.
Yes.
So when you resolve it into components, you use the same component to also find the direction. But here the direction is always from the north. Take your directions to always be coming from the north. Is there any question? Is there any question, class? Let me see check on your messages. All right. So that's it. So it's not difficult. It's not difficult. Okay, let's discuss something on relative velocity. We have about 32 minutes to end. So, Gideon.
So please, I think the one is to find for the alpha. So I think alpha is 37 degrees.
You got alpha to be 37 degrees.
Let's say.
Okay, let's see. Hmm. Hello, Gerard.
Sir, please, can you use cosine rule to solve it?
Yes. Okay, so if
Thank
you
you, sir.
had that, then add that to 90 and then use cosine rule to solve for P plus Q plus R. But don't forget you must get 6.22. Okay. So the next thing I want us to discuss is relative velocity. Relative velocity. Also under vectors. Then Thursday we'll look at Newton's laws of motion and then its application. Then we continue. Yes, we are extending our lesson by a week, and physics we'll do it. Okay. So relative velocity. In physics, whenever we talk about relative something, we are comparing that thing with another. So if you remember, we went through relative density. Relative density. The density of a substance, okay? The ratio of the density of a substance to the density of equal volume of water. So in physics, whenever we mention relative something, we are comparing one quantity to another. So with relative velocity, we are comparing the velocity of another body to one other body. So relative velocity compares the velocity of a body to another. Okay. Let's go practical. Then we look at the mathematics of relative velocity. You see, a colleague was riding a motor, and then when he bypassed me, I said, "Hey, Charlie, whenever you are riding, you must reduce speed because you were just over speeding. The speed was so much." Then he told me that whenever you are riding a motor, the rider does not see or seems to appreciate the speed he or she embarks on so much. However, an onlooker or a second person standing by the roadside would appreciate the speed better. Or okay, he being the one riding the motor sees his speed to be normal. But if you are an onlooker standing beside the road, then you realize that the person is really speeding. Please, are we following? Hello, are we there?
Yes, please.
So the true speed of a body is observed whenever one body is stationary. So if to appreciate the speed of a moving body, then an observer must be stationary and the body must be moving. Then you can appreciate that, yes, this body is really moving at a top speed. Another application of relative velocity is that, you see, most of the times when you are standing at the, when you are in one moving car and another oncoming car bypasses your car, then you realize that the fast moving car moves past you at that top speed. An observer in your car, in the slow moving car, sees the speeding car to be moving so fast in front, whereas another person in the fast moving car sees the slow moving car to be moving backward. Meanwhile, the car is moving forward. Please, have you made set observations on our road before where a car was speeding so much and an observer in a slow moving car sees the fast moving car to be quickly moving forward. However, another observer in a fast moving car sees the slow moving car to be moving backward, as if the car was moving backward when it bypassed it. Meanwhile, both cars are moving forward. Okay, so that illusion is due to relative velocity. Giovanni.
Sir, please, I don't get that explanation where the slow car is coming back in.
So there is, you see, there is a fast moving car and another slow moving car moving along the road in the same direction. But because one is at a top, moving at a greater speed than the other, when the car bypasses, the fast moving car bypasses the slow moving car, it's always an observer in a slow moving car would see the fast moving car to be moving forward, bypassing you, okay, with that speed forward. And an observer in a fast moving car looking at the slow moving car would also see the slow moving car to be moving backward. Meanwhile, both cars, okay, will be moving along the same direction. Please, has anybody made that observation before?
Yes, sir.
So that is what I'm talking about. Another illusion is that, you see, when two cars move with the same velocity, the two drivers can even talk. They can communicate and even exchange phone numbers. An observer in both cars watching the two drivers always appears as if the cars are not moving. So two drivers can be moving along the same direction at the same speed and they can be talking. Oh, what to say? Yesterday I waited for you. Didn't give me your number, and they can be exchanging. And when you are an observer watching both cars from the two cars, it always appears as if the two cars are stationary. Meanwhile, they are moving. Have you also made that observation before?
Yes.
This is relative velocity. It pilots two airplanes or aircraft also use that. And I'm even told that in the military, when two planes attain the same velocity, one plane can even refuel another because of equal velocity. So military personnel can move from one and refuel another. So when they attain the same velocity, that's what happens. So these are applications or they are everyday occurrences of relative velocity on our roads. In relative velocity, there must always be somebody doing the observation. There must be an observer or a term of reference or reference frame. So in relative velocity, there must be an observer. An observer who is doing the observation or reference. So who is looking at who? So the relative velocities of two bodies A and B. The relative velocity of a body A with respect to a body B is written as this. So when we are talking about the relative velocity of a body A with respect to B, the with respect to is the observer here. Okay, it's written as V of A, then B. So VAB means that we are looking at the relative velocity of A whilst it is being observed by B. So V of AB is equal to velocity of A minus the velocity of B. So the relative velocity of A with respect to B, meaning a body B moving with the velocity of B is observing or comparing the velocity of a body A with a velocity VA. So the relative velocity of A with respect to B is written as velocity of the body A minus the velocity of the body B. Then the relative velocity are we there? Class,
Yes,
are we?
please.
Okay. Then the relative velocity of B with respect to A. This time around, A is doing the observation. With respect to A, it's written as V of BA. Okay. When B was doing the observation, it was V of A minus V of B. Now, A is doing the observation, so it's V of BA. This is equal to the velocity of B minus the velocity of A. So this is the concept of relative velocity. Okay. This same thing is also termed as, if it's the relative velocity of a body A with respect to B, then it is the sum of velocity of A and the negative velocity of B plus the negative velocity of B. And V of B with respect to A is also equal to the sum of velocity of B and the negative velocity of A minus V of A. It becomes this because negative times positive is negative. That is why. So this is the concept of relative velocity. Please, is there any question? If you have any question, quickly ask me. Else, I'm checking roll call. So, Eda, Akusia, Nanakumi, Anita, Asida, Augustine, Barak, Caleb, Daisy, Elikem, Frank, Frimpoma, Genius, Saki Giovanni, Gerard, Wate Gideon, Hassan Abdallah Noble, Isaac Jacob, Yaila Jessica, Johnson, Marilyn Kujo, Marilyn Osetutu, Mary Michaela, Michelle, Nana Kwame, Wentiwa, Nicole, Ella, Ohene, Paddy, Imelda, Valerie, Yaubukwa, Yasmin, and then Miles. Okay. All right. So if there is no question, then class, this is where I'll draw the curtains on today's meeting. Okay. We'll continue on Thursday. All right. As usual, I'll post the assignments so that you try your hands on some questions. Until then, may the good Lord be with you, and bye-bye.